Hey, hi, welcome to Everything Embedded. It's been a while since I posted my video. So in this video, I'm going to be talking about the boot files which are present on the micro SD card, which is inserted in your Pi. So on the screen right now, I'm showing you my Raspberry Pi, which has been enclosed in a cool aluminum case with the micro SD card inserted into the Pi. So, or as you already are aware, but even if you are not, all the boot files or the boot partition is present on this micro SD card. So in this video, I'll specifically be talking about what are the various boot files which are present on the micro SD card, what are their functions, and how do they get copied there in the first place, which process actually does that, and where is the location of the kernel files, where is the location of the hardware device drivers, etc. This is just a beginner video, as you already know, and this should hopefully be a simple guide to tell you which files are used and what is their purposes. So let me start my Pi. Okay, so here I am on my Ubuntu machine. I have inserted a micro SD card into my Ubuntu machine here. So let me show you what I'm going to do is, so say I will make sure to watch my previous videos just so that you get an idea of what I'm talking about. So I have my Yocto, Poki, Raspberry Pi, temp, deploy, and these are my various images here which I have generated. So what I'll show you is I will so this is my image here, the SD card image I should add of the Yocto generated image for Raspberry Pi 4. So this image was generated using Yocto, and what I will do is I'll burn this image onto the micro SD card, and then we will examine the files and the files and the partition which are created on the micro SD card. So let's do that. And what I'm going to do is I'm going to use an application called as Balena Etcher. Make sure to install this application. It's a very useful application. Rather than using the complex DD commands, I prefer to use that, but of course it's up to you. So what I'll do is I'll go on to the location of my generated image here, and which I have is in the temp folder, deploy, images, Raspberry Pi 4, and I'm going to use this image and say open. I'm going to select my micro SD card here, say select, and I'm going to flash it to the micro SD card, enter the password. So it should do that in about 20 seconds or so. So once that is finished, we'll examine what is written onto the micro SD card. So just to reiterate the process, I'm using Balena Etcher to write the contents of the generated Linux image onto the micro SD card, and we'll see what is put on the micro SD card in just about now. So okay, so let's do that. Let it validate the micro SD card, what it has written to the card. Okay, that's it, it's done, and I'm going to pull out the card and put it back again just so that it gets listed here. Yeah, please connect it to my Linux. It should show up on the screen any moment now. Yeah, here it is. Right, so let's look at the micro SD card now. So here you see it has created two partitions here, and this is the boot partition, which is this one, Raspberry Pi. It has created two partitions on the micro SD card, and the other one is the file system partition, which contains the various applications and the programs which are intended to be running on the Pi itself. But in this video, we are talking about the other partition, the boot partition. So this is the boot partition, and these are the files which are generated. So what files have been generated here and what's the purpose? So just a brief look at the files. So we have first DTB files. As you can see, there are various device tree blocks here. Depending on the processor, or basically depending on the model of the Raspberry Pi, there are various different files. So all these files starting with BCM and the model number, which is the processor model number of the Pi itself, you get various device tree block files here. So there are various files which are present, and then you have the bootcode.bin. This is the initial file which gets loaded by the Raspberry Pi system on chip. So this is the starting point, and this in turn actually loads up the various elf files here. So you have start.elf, start4.elf, start4cd, start4debug, various kind of elf files. So it's the job of the bootcode.bin to load these various files. And then the other interesting bit is the kernel. So here is the kernel file. So depending again on the model of the Raspberry Pi which is being used, you could have different number of or the file name will be different. So in this case, I am using a Raspberry Pi 4. So here is a file called as kernel7.img. So this is the kernel which will be used for this version of Raspberry, in my case, which is Raspberry Pi 4. And other important file is of course the most, not the most, but it's a Commandline.txt. So this file is what are the parameters which needs to be passed to the kernel. So if you just quickly open it, that should tell you. So this is the command line which gets passed to the kernel itself. We will not go into detail into this one, what this one do. Maybe in the next future videos we'll do, but this just tells the Raspberry Pi which is the root partition and what are the various settings to be used, what is the file system type, and those kind of things. And then of course you have the config.txt file which has various settings for the Pi itself. What are the various settings which needs to be used, those kind of things. Whether the camera should be enabled, whether the USB mode needs to be enabled, whether the touch screen should be rotated, or whether the audio should be turned on. That's the kind of files here. So all these files are on the boot partition, and the other important folder is the overlay folders. Again, these are just the hardware drivers basically. So depending on the various devices which you connect to the Pi, so these are the drivers which are supplied by default. So if you use the latest version of the kernel, it may have in fact more drivers as well. So depending again on which kernel version you are actually using to build the Yocto image, you may have more or you may have less device tree blocks basically. So yeah, as you can see, so this is for the small 2.2 inch TFT screen, 2.8 capacitive TFT screen, and if you connect a DAC to your Raspberry Pi, so these are the device drivers which are supplied by default. So I hope this is I know is a very short video. What I'll try to do is I'll also list these files again nicely in a screen and column. That should like give you an overview of what are the files which are present in the on the micro SD card in the boot partition. So just to summarize what we did, we burned the image which we generated from Yocto onto the micro SD card, and we are examining the boot partition and just going through various files which are present on the boot partition, and I'll put them in a nice column so that you know which files are there and what's their purpose. Okay, let me exit from here.